Everybody knows that the derivative of x squared is 2x. But why? Well, you need the definition of the derivative. And the way that works is you need to plug in for f of x, and you're also going to need to plug in for f of x plus h. Well, f of x, it's right over here. It's x squared. So we just plug that in first, put our x squared right there. But f of x plus h, that's a little weird. Imagine I only asked you for f of 7. Well, the first thing that you would do is you would just notice that you're now replacing your x with 7. So you replace this x with 7, and you would have 7 squared. But we're just going to want to get f of x plus h. So instead of 7, I'm going to have to put x plus h. Now I have to square that. So because I got to square it, I need parentheses there. So it's actually x plus h squared. That is all equal to f of x plus h. So we're going to put that in right over here. Okay, so now the top can actually expand to x squared plus 2hx plus h squared. So that's just some algebra. And then minus our x squared. And now on the top, we get a nice cancellation. So it turns out it just becomes 2hx plus h squared. And that's all over h. And it's also the limit as h goes to 0. Now, if I try plugging in this 0 right now, I got a problem where I'm going to be very upset with you because you're not supposed to be dividing by 0. So turns out what you want to do is factor the top. And when you factor the top, you're going to get 2x plus h. On the bottom, we have our h, but that h that I just factored out is going to cancel here, which relieves our little problem. So now when I take that 0 and I plug it in, I'm not having to plug it into the bottom anymore. The only h that's left is right there. So it's going to be 2x plus 0, which is 2x. We proved it. All right, we did it. We proved the derivative of x squared is 2x. So you could do something similar if you wanted to prove the derivative of x cubed, or maybe you wanted to prove the derivative of x to the n. And in general, you would say that the derivative of x to the n is nx to the n minus 1. And you would use a similar idea to this. It's a little bit more complicated. You need to know a little bit more pre-calculus, a little bit of combinations, but it would still follow the same process of starting by plugging into the limit definition of a derivative. All right, so in the future, we're just going to use these simple rules, and we're just going to tell you, oh, by the way, for this one, you just have to do 3x squared, and we're going to have all sorts of other rules that come up in calculus, but they're all based upon the limit definition of the derivative. See you guys later.